So isa sa application sa sa derivative or differentiation is to know how a function would behave when it is graphed. So makita na to, mahibalaan na to, unsa ang itsura, mas ma-figure ma-describe na to, or again ma-illustrate na to kung unsa ang itsura sa graph pag i-graph ang isa ka curve. So pag mag-graph mangud ta og, di ba, mag-graph ta og say a line. So magkuha lang tag value of x and y, and then mo na to sana isa-isa og plot. But when you are given a curve, so usually naay mga naay times na duha ka points, you are given x, so naay times na duha ka value sa y. So ang inana na case kay would appear with parabola, ellipse and hyperbola. So naay mga times inana, so maglisod na ta graph. So one thing that is very nga pwede na to magamit in terms of describing how a curve would behave is through the first derivative and the second derivative test. So with that, we will be discussing it in this video. So first, we will tackle on increasing and decreasing function. So with the first derivative or the first derivative test, may bala na to if ang function is decreasing or increasing in that certain intervals. So what are those intervals? So how can we say na increasing ang function or decreasing ang function in that certain interval? So that ang gamito nato is ang first derivative test. So how do we use the first derivative test? First, we need to find the first derivative of the function given. So we are given with this function y is equals to x cubed plus 3x squared minus 9x plus 7. So muna natay function. So since first derivative test ni, so pahitaon sa nato ang first derivative. So the first derivative is that 3x squared plus 6x minus 9, and then we will be equating that to 0. So meaning y prime is equals to 0. And then we will be solving for the values of x. So solving for the values of x, we have two values of x, kay x squared man. So natay duha ka x, so we have negative 3 and negative 1. These are called critical points. Critical points, and they will be the markings of our interval. So to illustrate this interval, akong ginaingon, so we have this graph. So although na graph wala pa to kabalo aning graph, so ang intervals would appear at x equals to 3. So kana, so in some videos makuha ninyo as the sign chart. So at these intervals mo ni siya ang mga mahimong intervals. So from the negative infinity to negative 3, our first interval. Our second interval is from negative 3 to negative 1. This is our second interval, and then our third interval is from negative 1, x equals to 1, right? Our second interval is from negative 3 to 1, and then our last interval is from 1 to infinity or positive infinity. And then ayos nyo yung kalimtining critical points kay magamit na nato later. So with that, our intervals would be negative infinity to negative 3, negative 3, 1, and then 1 to positive infinity. So makita ninyo, if we have 2 critical points, our intervals tulo pod. Kung duha lang, isa ka critical point lang, so our interval is duha. Kung tulo atong critical points, so upat ato ang interval. So inana lang. So since nanata intervals, para asa man interval, so kani siya ato magamit sa first derivative test. So gamito nato balik ang first derivative. Gamito nato balik ang first derivative. So kung kani ang intervals, mamili ta og value within that interval. Mamili tag value within negative infinity to negative 3, negative 3 to 1, 1 to positive infinity. Mamili ta dira. And then muna siya atong ibalik og substitute sa first interval diri So pagbalik na tong substitute, if your first derivative is greater than 0, then your function is increasing in that interval. Kung naman it is less than 0 or would have a negative sign, so that function is decreasing in that interval. Okay? So since we are now using our first derivative test, so we have our first derivative as this. So ang first interval na to is negative infinity to negative 3. So mamili daw tawag interval, mamili tag value within that interval. So say it is x is equals to negative 4. So substitute na to ang negative 4 sa first derivative. So our y prime is equals to positive 15, which is very much greater than 0. So therefore our function is increasing at this interval. So pasaka daw siya. So if kuha na to diri so makita ninyo from this in this interval we have tanggalan na tong grade. From this point, from the negative infinity to negative 3, so pasaka ang ato ang function. Pasaka siya di So pasaka siya. The slope is, again, di ba, first derivative kay slope, so pasaka siya. So muna. Ay, pwede na ako napakita, sorry. So makita ninyo if we try to illustrate that, so from negative infinity to 3, negative 3, so makita niyo ang function pasaka because the slope or the y prime is pasaka and the slope is pasaka. So it is increasing in that interval alone. And then moving to the next interval, so our next interval is negative 3, 1. So mamili gapon ta og value nga tunga-tunga dira and then i-substitute nato sa y prime or the first derivative. So makakuha tag negative 9. And then since it is negative, therefore the function in that interval is decreasing. So makita nato so dara. So negative 9. So decreasing, again gi-substitute lang nato ang negative 2. So makita ninyo sa kana nga interval, dire na interval from negative 3 to positive 1. So kana negative 3, positive 1. So ang function nato is decreasing. So nagapababa siya. Dire na interval lang. And then last interval, di ba, ang last interval is positive 1 to positive infinity. Again, same process, namili ta og value na tunga-tunga dira any value. So makuha ta let's say x is equals to 2, so makuha tag value of 15 and then it is increasing. So illustrating, so you have positive 1 to infinity, our function is increasing in that particular interval. So therefore, at these intervals from increasing, so ma-imagine na ninyo gamay kung saan mahimong itsura sa graph. So increasing at the first interval and then decreasing at the second interval and then increase na po siya at the third interval. So if I illustrate that using wala pa yun na kabalo. So di ba again we have this, and then if this is 0, this is 0, and then this is 1, this is 1, 2, 3, so negative 3. So this is our assigned critical points. So going to the left, we have negative infinity. Going to the right, we have positive infinity. So if tungaon doon na nato, so we have that. So our first interval kani, second interval kani, and then so ingon siya, our first interval daw increasing kay nakuha man tag 15. And then pag abot sa second interval, nag-decrease siya. And then pag abot sa third interval, nag-increase na pud siya balik. So hinahina na ninyo og imagine ang function or ang graph sa function through the first derivative test. So, ana. And then since di ba I told you nga dili sa ni kalimtan, so ang critical points. So kanang critical points, they are also the location of the local maximum and the local minimum. So same gihapon, when we use y prime is equals to 0, we will get this values. So pagkakuha nato anang values sa x, makakuha po tag values sa y. So muna siya ang mga values sa y. Pag direct substitute, asa na to siya i-substitute? Dili na sa first derivative, dito na to siya i-substitute balik sa main equation kani. Dito na to siya gibalik og substitute para makuha na to ang value sa y. Therefore, ang critical points are at negative 3, 34, og 1, 2. So, say pasabot ana. So, balik ta dito sa graph. So, di ba, as we solved earlier, sa first interval, increasing siya. Pero, pag abot sa negative 334, kay mo man daw ni ato ang critical points, dito siya ni balik and dito siya ni baba. Dito siya ni baba. So pagbaba niya dira baba, and then at 1, 2, dito po siya ni balik og saka sa 1, 2. Okay? So those are the critical points or the local maximum and local minimum. So how do we know if it is a local maximum or local minimum? So we just have to use the first derivative test. So ang first derivative test, indication po siya if your critical point is a local maximum or local minimum. So if your y prime goes from, di ba, kaning negative 3 kay tunga-tunga siya sa first o second interval. So if ang kana siya ang ihang intervals is changing from negative to positive, it is a local minimum. If it is changing from positive to negative, therefore it is a local maximum. So inana ang yahang puan. So again, if negative siya, then may mo siya positive ang first derivative test kani. So it is a local minimum. Kung positive naman to negative, may mo siya local maximum. So again, na-solve naman nato siya ganina. So we have here for x is equals to negative 3. I mean, for the points negative 3, 34, di ba? Di ba ang ihang tunga-tunga siya sa negative infinity 3 and 3, 1. So, ang y prime niya, pag kani atong gamito na interval, positive. Ang y prime naman, pag kani atong gamito na interval is negative. So, since nag-change ang sign sa atong y prime, therefore, nag-change ang sign, therefore, it is either a local maximum or minimum, pero unsa siya sa duha. So, pag from positive to negative again, therefore, it is a local maximum. So, another is for 1 to 4. 1, 2. So, tunga-tunga siya aning duha ka intervals. And then, using the first derivatives, yapon in these intervals, we have negative 9, na mo siya positive 15. So, from negative to positive, therefore, it is a local minimum. So, what if, sir, ang y prime na to is positive, walay changes, positive lang siya both. So, it could be your kana nga point is a point of inflection. So, unsa ang point of inflection? Which ma-discuss na nato later ang point of inflection. Pag ang y prime wala siya nag-change og sign, positive lang siya. So that is point of inflection. So again, if your y prime changes from negative to positive, it is a local maximum. If your y prime changes from negative to positive, therefore it is a local minimum. So moving forward to our next topic, which is concavity. So as I've mentioned earlier, what if our y prime doesn't change signs? So moto siya ang mahitabo kung ang katunga point is a point of inflection. So naay cases wherein inyong critical points ma-solve diri is a point of inflection. So unsa ang point of inflection, sir? Ang point of inflection dira mag-start og change, mag-start og deviate ang concavity sa imuhang graph. Unsa ang concavity? Concavity is like this. So, di ba ang concave sa mga glasses kay murag siya cave. Di ba na duha ka types of glasses, concave and convex. Concave is katong naibura og ito inani concave is like this. Convex man eh. This one is a convex. Pero if we imagine it like this and then looking from this side, tanaw na to siya from diri concave siya, na siya murag bangag or murag bowl. So kana concave. And then there are two types of concave. We have concave up and concave down. This one is a concave down. So pababa ang iyahang banga ay sa baba ang naga-face ang bangag, and then concave up pag iyahang bangag is naga-face upwards. And then napo yun na siya duha ka types. So we have concave up decreasing, decreasing because nagapababa ang iyahang iyahang direction, and then increasing pag nagapataas and direction. So napoy concave down na decreasing, naga-decrease iyang naga-face pababa, then decreasing pa jud, and then we have concave down also increasing. So how do we know if our function is concaving downwards or concaving upwards? So we will be using the second derivative test. So since we are using second derivative test, so kuhaan po na to ang second derivative. So again, same gapon ang atong example na gamiton. So we have this, and then pag makuha na to ang y double prime or the second derivative, equate na to sa 0, and then we will solve for the value of x. So here we have the value of x is equals to negative 1, and then we will be again imagining it sa isa ka number line or sa graph, since na naman taan ni. So di ba na picture out na nato siya nga pag abot sa negative 3, 4 nagababa na siya, then pag abot sa negative sa 1, 2 nagasaka siya, pero asa siya in between diri nagsugod og saka, and that is at x is equals to negative 1. So diri na point. So pag kuan diri di ba concave, we have wala pa rin nato na check ang concave. So kung concave down ba siya o concave up. So nanataan ni. And then we have intervals. Magbuhat ka puntag intervals. So ang interval, since isa lang kabuk ato ang point, isa lang kabuk atong na-solve na value sa x, so duha lang ka intervals. So ang intervals nato dira is from negative infinity to negative 1, and then negative 1 to positive infinity. So kana karon atong duha ka intervals, and then ang duha ka intervals nato muna siya tong gamiton para sa second derivative test. So sa second derivative test, same gapon atong gamiton isang second derivative, and then mamili lang ta og values diri. So for the first interval, we have that. So we have 6 times negative 2. Our second interval is negative 6. The value of the second derivative at this interval is negative 6, which is clearly less than 0. So since y prime is negative or less than 0, it is concave. Ano upward ba ni? Should be downward. Downward. Ano pa? So it is concave downward. So wala din ako napakita, no? Ang graph ako nakita. So sorry. So again, using the second derivative test, we have y is equals to that. And then solving for the y derivative, we have 6x plus 6. Solving and then equating that to 0. So we have this. Solving for x, we have this. And then, since isa lang ka point, we have two intervals from negative infinity to negative 1, and then negative 1 to positive infinity. And then, for the first interval, mamili tag number between that interval. So say we have negative 2. So let x is equals to negative 2. So muna to siya i-substitute sa atong second derivative, and then solve for its value. And since y double prime is negative or less than 0, it could be concave downwards. So from that interval, tanggalon na natin in in that interval, your function could be concave downwards. So umani siya ato ang interval from negative infinity to negative 1 and then negative 1 to, so makita nato diri nga concave downward siya yung function. And then for the second interval, same gyapon, mangita tag value sa mangita tag value in between that, so say 0 ang x. So we have y double prime is 0, which is 6. So we have 6 is less greater than 0. So since y double prime is positive or greater than 0, then it is concave upward. So makita nato diri sa graph, we have pag abot diri nag-start na siya og start na siya og concave upward. Yes, mo ni ang tunga-tunga. And then therefore since nag-change siya, nag-change ang sign and or also from concave downward to concave upward, therefore there is an existing inflection point. So to solve for the inflection point, we just have to use the second derivative. So makakuha tag negative 1. And then if x ang negative 1 sa inflection point, so what is its y value? So to solve for its y value, input lang nato siya dira Pag input nato siya dira sa tong equation, main equation, so nakasolve ta og y is equals to 18. So therefore, the inflection point is at 318. Okay? So ang inflection point or mag-start og change ang concavity subgraph is at 318. Ano 318? Negative 118 din. Negative 118. So makita niyo sa graph kana, so di ba increasing, and then pag abot niya diri sa local maxima, baba siya, decreasing, and then pag abot niya sa negative 1 to 8, nag-start og change ang concavity. So di ba ang concave downwards, nag-start na siya change diri concavity until such time abot siya sa 1 2, then balik siya pasaka. So that is how you solve for this is what an application of differentiation looks like. One of the application. So describe na to how a function behaves on when it is graph, specifically for curves. So I think that would be it.